So as far as the review goes, the first thing they're going to talk about is just the asymptote. It says, where is the asymptote for the graph y equals 3 to the x? Remember, an asymptote is a line that your graph approaches but does not cross. The easiest way for you to probably find it is just put y equals 3 to the x. Let's just put that in your calculators. So into y equals 3 raised to the x. And when you look at the graph, you'll notice it probably takes a while, and then you'll start to see it show up about right here. And then the exponential function, of course, hits that curve and goes up. But it's coming in next to this line right here. What is this line called? The x-axis. All right. So that's where your asymptote is. It is on the x-axis. Or if you need like a more formal name for it, the equation would be y equals 0. So then let's see what happens on this next one. If we'll put in here y equals, we're going to change it 4 raised to the x plus 3. So yeah, definitely moved it up. But do y'all see that line coming in? See how it gets close to that straight edge? It doesn't ever dip down in this part. So it comes in right here, and then it hits that curve, and we'll go off. Look where that line is. What is it close to? What value? We got 3 or 4. It's going to be the 3. What they did was they picked it up. Remember earlier it was on 0? So that plus 3 picks that equation and moves it up 3 units. And so now where your asymptote is, it's at y equals 3. All right, so if you were to look at this next one, y equals 1/2 to the x minus 4, before you put it in your graph, where do you think it's going to be? Negative 4. Be at negative 4. The 1/2, what you should notice when you graph it, instead of having an increasing function, can get that out, it should be decreasing. It's going to be going the other way. But even though it's decreasing, you'll notice that still, down there, once it hits about negative 4, it curves off and it goes off in that straight line. It won't ever cross that. All right? So your asymptote is at negative 4. So when we are looking for the asymptote and those values are shifting that graph up and down, correct? Which leads us into number 2 down here. It says, how does y plus 2 equals b to the x move the parent function y equals b to the x? Right. Here's what I need y'all to remember. All of the equations that were up here, even though they were asking about asymptotes, we noticed they were being moved. They're all y equals. Do not answer this question on your test until this y plus 2, until you have y by itself. So when I look at this, y plus 2 equals b to the x. How do I get y by itself? Minus 2. So it's b to the x minus 2. All right, now, even though you don't know what the base value is, what do you know this minus 2 is going to do to the graph?
To make
move it down 2. Make the asymptote be at negative 2. So what we're going to write is it will shift the parent function down 2 units. Please, on the test, do not answer that question until you have the y by itself. Okay? I know what that was. Make sure the y is by itself. Okay? Then y'all shouldn't miss that one. That's the only thing I can tell you about that. That's why people miss it. On 3. We're going to tweak this question a little bit so it matches up what your test looks like. A certain type of bacteria doubles in population every, and then right now it says 6.5 hours. The one on your test is just going to say every hour. So we're going to make it like that, every hour. There were approximately 100 bacteria to start with. The first thing that they want you to do is write an equation which expresses the number of bacteria B after T hours. There's nothing in here about growth or decay. All right, so this is a straightforward exponential equation. You're looking to fill in the A times the B raised to the X. You need to find an A value and a B value. All right.
Would the A be 2?
Okay, the A is the amount that you start with.
Oh, so it's
So that would be what? How many did we start with? 100. So the A is the 100. All right. You says that we started with 100 bacteria.
Okay, teachers, it's time to send our first group of seniors, if they are here. Cesar Abreu through Ashley Cornelius out to the auditorium.
All right. The B value you can find in a table with successive ratios. Of course, we don't have a table. It's also what you would multiply by as you move down the table. So that's the 2 that you're getting. Where it doubles in population, that's going to be your B value. So that would be here. And so they asked me on this to use the letters B and T. So I'm going to use after T hours. And over here it would be B equals. So the bacteria will equal 100 times 2 raised to the T. So y'all keep in mind the 100 came from what you started with. That's your A value. This doubles. Told you what your base was with that X on it.
Why would it be B instead of Y over there?
Right here it says the number of bacteria B after T hours. They just specifically asked to use B and T. On part B, it says how many bacteria will there be in 4 hours? Now that you have an equation, all you have to do is plug in 100 times 2 to the 4th. 1600. Everybody get 1600? I'm going to make sure I put it on the screen so everybody can see how to enter it. There it is. 100 times 2 to the 4th. I agree with Bo. I got 1600. Everybody okay with the calculator part? All right. Over on the side, on number 4, it says, which of the following table of values could be exponential? Guys, with tables, you're looking for successive ratios.
C.
We will see. Here's the deal. The successive ratios have to be the same all the way up and down the table. That's what's special about exponentials. If you start on A, if I take 4 and divide it by 1, I get 4. Oh, sorry. And then 9 divided by 4 gives me 2.25. Those are not the same.
Oh, okay.
That's not my answer. All right. When you look down here at B, you've got 9 divided by 3. That is 3. 27 divided by 9 is also 3. And 81 divided by 27 is 3. That's the one that's exponential. You want to be careful of things like C. You'll see they've got 4, 8, 12, 16. They're adding 4 each time. That's linear. All right, and that's not what we're checking for. I'm just going to do a couple of them so they're on here. And so we know why they're not exponential. That one gives me 2 and 1.5. This one, 35 divided by 14 would be 2.5. And 60 divided by 35, about 1.71. That's why those don't work. Do you have any questions about the first page? On 5, fairly straightforward. You just want to be careful with the variables, what the variables represent. It says the length of time in hours T that milk will stay fresh depends on the storage temperature in degrees Celsius S. Because bacteria grow exponentially, you can assume freshness decays exponentially. The equation below models this situation. So not the prettiest number right here, but at least they give it to us. And then it says, how long will milk keep if it is stored at 16 degrees Celsius? You need to plug this 16 into the equation. What you got to be careful of is where you plug it.
16 for the S.
16 is for the S because it says that S is degrees Celsius. Y'all kind of know that degrees Celsius is a temperature. You may think, oh, I'm going to plug it in for T for temperature. But remember the T was the time and hours. So that's what you have to be careful of.
C, put it in the,
So all we're gonna do is plug it in up here for S. Of course, that'd go in your calculator.
Messes it up.
You could go ahead and subtract 16 minus 4 and put 12 up there. If you don't even want to do that much math though. What I would remind you of is when you raise it, make sure you put that 16 minus 4 in
Our next
parentheses.
group of seniors to report are Kara Calzer through Jessica Hayes. Kara through Jessica.
Alright. Did y'all get about 63.6? Alright. I just want to double check on the calculator stuff.
oh, you don't put in y equals, do you?
No, you don't put in y equals because we know everything. You just put it on your home screen.
I
So-
put in,
You'd get the same thing, I mean, if you wanted to. Probably have to look for it a little bit. Did y'all get 63.6? Alright.
No.
You did not? There, can you see the screen now? Did you do
Yeah, I
12
did.
or did you?
Sorry, I
Oh,
thought
you do
you
have
had
it?
seen.
Alright. On number 6, it says the population of Summerfield in 2007 was estimated to be 16,000. Starting in 2007, the population increased annually at a rate of 7%. After how many years T will the population be equal to about 31,474? So do y'all see where it says it's increasing? This is one of our equations that has to go with the exponential growth or decay. And so the way that looks, you'd have A of T, this is the amount after a certain time, is going to equal A sub O, that's your original amount. And it's always going to have a 1, and then you're going to decide for the situation whether it's a plus or a minus. What's it going to be in this case if it's increasing? Plus. So we'll put plus our rate raised to the T. The amount that we had after a certain time period is this 31,474. The A sub O is the original amount, 16,000. Of course, it's 1 plus, our rate would be 0.07 raised to the T. Alright, this is a little tricky having that exponent up there. But the beauty of this, on the way it works on your test, multiple choice, right, with these times, we need to figure out which one of these times is going to give us this answer. Alright, so you're going to plug in. What do y'all want me to try? 10? Or 10 first. We'll try it.
That's right.
16,000. And then parentheses, I'm going to have 1 plus 0.07 raised to the 10th. That's the answer that came out. Pretty close to what we were looking for? That'd be the answer. Of course, if 10 didn't work, you just try another one. 7, 8, and 9, these we're going to actually solve. On 7, it has 3 raised to the 5x plus 5 equals 9. What was the trick for solving these? What would had to be true about these base numbers?
They have to be the same.
Have to be the same. Alright, so I'm going to leave it as 3, 5 to the x plus 5.
3 squared.
9 will change to 3 squared. Alright, once the bases are equal, you're going to put the exponents equal to each other. It's kind of like the bases disappear. And we're going to solve 5x plus 5 equals 2. So make your zero pair, divide. I should end up with that fraction.
Can we leave it as a fraction?
You can leave it as a fraction. Mhm. Just reduce it. If it's something that can be reduced, reduce it. All right. 8, it looks a little different than number 7, but it's the same idea. You're still just solving. This says y equals 3 to the x plus 4, which is equal to 27 to the third. And then you want the value of x.
So it'd be 3 squared.
It will be. We're gonna keep this 3 to the x plus 4. And then what I heard out there was this 27, we're gonna change to 3 cubed.
And then it comes at 3.
Yeah, that exponent of 3 on 27 cubed, that's still there for right now. It will become a 9. Because to raise a power to a power, we're going to multiply those, so that we 3 to the 9. All right, now the bases are the same. And so you'll put the exponents equal to each other.
X equals 5.